Hey, what's up, everybody? Welcome to TGIK this week. Today is Friday, June 22nd, and we're doing an episode on Kubebuilder today. I'm back in the hot seat, or I guess I should say hot treadmill, because I'm not sitting down, I'm actually standing on a treadmill right now, doing a TGIK on Kubebuilder. Looks like, hold on, I got some feedback coming back. Let me mute my screen here. Now's for everybody's favorite time of the week. Let's say hello to everyone. So let's do hi Felipe, the first one. Suresh, we have Craig, Olav. Good afternoon from Copenhagen, Denmark. Good to see you again. It was great visiting Copenhagen for KubeCon earlier this year. Greetings from a Cube farm west of Washington, D.C. Awesome. Sunshine today, but raining in Florida. Hey everyone. George, good to see you. Thanks for helping out this week. Lamatti, great to see you again. George says, can you refresh the notes file? I updated it. Let me do that now. Joe says, well, my headphones are definitely working. My TGIK alerts just fired and made me jump. That's awesome. I'm glad to know folks are getting the TGIK alerts and that system's working good, but sorry that it was super loud. My bad. Hi from Senegal. Good to see everyone. Awesome. Well, let's get started. So this week, as I mentioned, we're doing Kubebuilder, but first we want to do This Week in Kubernetes. So let's switch on over. So like always, we now have our lovely markdown file in our TGIK GitHub repository. This week, it's episode 40. We're doing Kubebuilder. I'm your host, Kris Nova. And we have our lovely image, and I think this is a link to the live stream and ultimately the recording, if folks want to check it out. And then also a friendly reminder, we have a pointer here on the home page for quick and easy access. You can just click the Watch Live Now button, and that should always go to the most recent stream that we're working on. We have some show notes that we'll be updating as we go, and I'm going to be working out of this directory. And I guess real quick, that really is a good segue of something that I was thinking about earlier this week, which is now that we have an open source GitHub repository, every time we do a TGIK, we create one of these episodes directories. And if you look, Joe did this a little bit last week, but now each person has a small directory they can put whatever they want to throughout the course of the episode, and this becomes like their working space for the episode. So I've already got the TGIK repo checked out, and we've got a branch checked out, so we can go ahead and update that throughout the episode as we move forward. So scrolling back down, let's do some quick updates this week in Kubernetes. The first one is we have the ClusterCuddle release. So for folks at home who don't know, I'm one of the organizers for the Cluster API working group underneath the SIG cluster lifecycle, SIG in open source Kubernetes. And we just released our first tool here. If you see, we have 2 releases, and it's this tooling called ClusterCuddle. And what ClusterCuddle is it's an example of how folks in the community are coming together and starting to think about deploying Kubernetes clusters in a standardized way. So it's a command line tool. It uses Minikube to start up a cluster, and then we deploy controllers from then on, and actually brings up different variations of the cluster API. So as we look at the cluster API and as we get different implementations growing in open source, we're actually going to be able to use this tool to get us up and running and get a Kubernetes cluster up and bootstrapped. One of the things we were looking at today, let's see if I can find the issue for it, was cloud provider, I think it's this one here. We started looking at renaming, the various cloud provider repositories in the cluster API. So now we're having folks like GKE's going to get one, Amazon's going to get one. I know Marco was talking about making one for DigitalOcean. There's a lot of folks who are talking about making this new compute level repositories in the Kubernetes SIGs organization for deploying cluster API implementations. So in here, if you want to come and contribute, we would love for you to come in and cast your vote. It looks like vote for number 3 is winning right now, of how we should name these repositories moving forward. And how you do that is you just read which one of these you agree with the most and come down here and give us a thumbs up if you want to vote. So we'd love to hear your feedback, and we are really excited about seeing ClusterCuddle and the different flavors of the controllers up and running in open source moving forward. So actually, let me add a link really quick right here. And I'm going to cheat, and I'm going to edit the markdown directly in GitHub, so don't tell anybody I'm doing this. But we can come down under ClusterCuddle, and we can 1, 2, 3, 4 add a little sublink there, so folks at home can get a copy of it. Bam. Okay, coming up next, we have this Google Platform blog. GPUs as a service with Kubernetes engine are now generally available. So big shout out to our friends at Google. Congratulations, GPUs as a service with Kubernetes is now available. If you were at KubeCon earlier this year, you saw a talk that I did with David Aronchek, and you probably also saw his keynote talking about all the different ways of getting TensorFlow and Kubeflow up and running with Kubernetes. So I'm imagining that this is just going to be an extension of that and another way for folks who are taking advantage of GKE, who are interested in running any sort of GPU workload, which is, machine learning and training your model and doing all of that like fancy AI stuff that I have no idea how it works. GKE is now a good place for you to do that. So big shout out to those folks. Up next, we have this blog I saw on Reddit earlier today. It's called The History of Kubernetes. And I didn't give it a full, thorough inspection and go and fact checked everything, but everything I saw off the cuff actually looked pretty legit. And it's cool because it starts way before Kubernetes actually was released in 2014. If you guys remember, a couple weeks ago, Joe had helped co-author the blog about the 4 years in open source, and this timeline actually begins in 2003. So almost a decade before the whole Kubernetes thing even came out to begin with. So this talks about Borg and how they moved to Omega and then ultimately released Kubernetes in 2014. And then it jumps into the open source timeline, which is where open source got involved, and I started to sort of poke around at this and then ultimately turned into what it is today. So this is pretty cool and kind of glues a lot of things together, and you can sort of see all the different Kubernetes releases and understand how all of those fit together. So that's a cool blog to check out as well. So up next, we have Scaling Kubernetes. It looks like this was written by Brendan Rios. And let's see what we have here. So I think George just added this one, so I don't even know what we have here. So let's go see. When moving more than 500 containers to K8s, we ran into some problems. Scroll down and read the big titles below to see how they were and how we solved them. Okay, cool. So this looks like a good blog. George checked it out, see what's going on in chat. And we can move on. Cool. So next we have AWS cost savings by utilizing Kubernetes ingress with classic ELB. Hold on, I'm going to get some water here really quick. So this looks like a blog about how folks are able to save a little bit of money using the classic ELB with AWS. So this is pretty cool. I wonder where this one came from. So an article about an Nginx controller. This article was actually the second most popular blog post, and it focused on the Kubernetes ingress for on-premise deployments. Cool, and it goes in and explains how it works and talks about all the different ingress deployments you can install. Oh, this looks really cool. I definitely want to come check this out. So this next one is a pretty exciting blog I found earlier today called the Heptio Authenticator, which is an open source tool that we released, and how it works with Helm. So Joe did a really great episode last week about all the different ways we can authenticate using Gangway and Dex, and this looks like an example of how to actually come in and do this with Helm. So another great blog there. So what I'm learning is throughout the week we've had a ton of great blogs in Kubernetes open source. Shout out to our friends at Arc. They finally released the 0.9 alpha. So come check this out, give it a spin. We keep talking about getting Andy in here because we really want to do Arc. I've done some really cool Arc live demos at KubeCon, and anytime I go to a conference, I always make it a point to do a quick demo live at the booth. So if you want to come swing by the booth at one of the conferences I'm at, I'm happy to show Arc for you. And we're trying to get a more rounded out way of actually doing an in-depth TGIK on Arc moving forward. But the project's growing and it's really exciting. Cool. And then we have some more reference links down here at the bottom. So real quick, I'm going to check out chat, and then we're going to jump into Kubebuilder. All right, let's see what we have here. We have more folks saying hi. I was hoping that you could quickly talk about ingress best practices. If you have a bunch of services, should each have its own ingress, or should be a unified ingress for your services? So this is talking about how we map a single ingress to multiple services. So right now, the way ingress works is you can define multiple endpoints and point those at different services through different ingress rules. The only way I've ever set it up is having one monolithic ingress, and then I split that out to point to different services in my cluster. I would defer to Dave Cheney, who's done some work on Heptio Contour. He can probably speak a little more intelligently about pros and cons of having more than one ingress to point to different services. But that's a great question, Aaron. Lamati, Aaron, there's a great article up on that topic. I'll submit a PR with a link to the article. Kris Nova probably has some super cool ideas, though. Maybe she'll give her thoughts. There we go. Just did. Yeah, I just thought through the lessons learned were interesting to this group. Yada, yada. Aaron says, Joe says, Aaron, for what it's worth, I would generally use one ingress controller. Yeah, that's exactly what I was just saying as well. George, really quick, a comment on Arc. This version of Arc has rustic support in alpha, and feedback testing in the area would be much appreciated. Awesome. And then real quick, I'm going to crack the door because I am already sweating in here. It's getting pretty hot in the room. Okay, rad. So let's jump in to Kubebuilder. Cool. So real quick before we go into the code and actually jump into the command line, this is a good opportunity for me to talk about the Kubernetes SIGs organization. So this is a new organization, and it's like, when I first looked at this about a month and a half or 2 months ago, there was only a handful of repos in here. And if you come in, you can look and actually see that we've grown quite a bit. And the way this works now is any repository that a Kubernetes SIG is responsible for is supposed to be stored in this new GitHub organization. And then all of this code is managed by a corresponding SIG and then usually attached to like a working group or a sub-project or something that would come in and actually maintain the code or maintain the project moving forward. So we've got the cluster API, let's see if we can find that in here, which is one of the main working groups I'm involved with underneath SIG cluster lifecycle. And the one we're looking at today is called Kubebuilder, which is underneath the API machinery Kubernetes special interest group. So this is the tool that we're going to be playing with. And you can find it at github.com/kubernetes/kubebuilder. And I think in the same way that Joe kind of likes to go and poke around at YAML, one of the first things I always really like to do whenever I'm exploring a new project is just come in and get a feel for the repository and see the way things are set up. I feel like you get a really good idea for the type of engineering behind a repository, just coming in and just trying to find the main function right away. So I picked this up earlier this week, and I try not to like learn too much before an episode of TGIK, but I try to learn just a little bit to kind of get my feet wet and kind of get me excited. So I came into the CMD directory, came in here, I found Kubebuilder, and then bam, main.go. And this is where I always start looking at a project and kind of understanding what's going on here. So one of the first things I noticed is we have our main function and we have a Cobra command. Again, we see this pattern all over Kubernetes. It's an easy way for us to define like a Kubebuilder command and then add like various subcommands after that. You know, things like Kubebuilder create or Kubebuilder generate, and you can sort of define those commands as you need them as a software engineer. And then you can come in and you can add some text here in the long description and talk about all the different ways you can configure and run your command line tool. So Cobra's a great library for helping out with that. Down here at the very bottom, we have this run main command, and it calls command help. And this is how we enter our program. And then if we come back to Kubebuilder, I bet, yep, we can find all of our various subcommands here as well. So here we have init, and we have run, and we have update. And I bet as we go through the documentation today, we're going to come through and actually run some of these commands as needed. So first things first, let's install Kubebuilder. Okay, so coming to the repo, let's go to the main page here. And the first thing we notice is it says, do not use go get or go install. You must download a tar binary release or create your own release using the release program. To build your own release, see contributing.md. So to be completely honest, the first thing I did when I found the Kubernetes repo here is I typed go get, github.com, Kubernetes SIGs, Kubebuilder, and of course that didn't work. So I came back and read the documentation. But it says we want to download a release, so let's do that. So releases are here. And the way these things work in GitHub is you can come in, you can download the tarball and extract it, and hopefully if all goes well, you should have an executable ready to go because Go compiles to a statically linked binary. So we want the one for Darwin since we're running on my MacBook. So let's click there and let's grab it and let's jump into my terminal. Cool. So I can go to my downloads directory and I bet I can move Kubebuilder, and I'm going to kind of do the cooking show thing since this is still downloading in the background. It's a pretty large file. It's 118 megabytes, so I'm kind of curious to see what all we're downloading, but I've already downloaded this beforehand, so we can actually move this to our TGIK repo and untar it there. So let's go to go, source, github.com, Heptio, TGIK, episodes, 40. Let's go here and see what we see. source, github.com, Heptio, TGIK, episodes 040. Whoop. There we go. So tar minus XCF to untar, Kubebuilder. See, like I mentioned, this is 118 megs, so I'm curious to see what's going on here. And hey, Engin from Turkey, I'm trying to keep an eye on the chat and kind of untar at the same time. And let's see what this untarred to. Okay, so this is me, and I'm really grateful that the folks who built the Kubebuilder release did it this way, because sometimes you'll untar a file that is called one thing, and it'll untar to a directory called something completely different. Which usually when I'm doing this, it's in my downloads directory, and if it gets called something else, it's pretty much gone forever because I'm not able to find it. So in this case, thanks for keeping the naming convention standard there. It's greatly appreciated. So if we go into Kubebuilder, let's list and see what we have in here. We have a directory called bin. Let's go check out bin. And here we have, ooh, what do we have here? We have a bunch of stuff. Looks like this is all pretty familiar to folks in Kubernetes land. So we have client gen, conversion gen, deep copy, defaulter gen. So these are all command line tools that the API machinery special interest group has built for us that we can use to generate various parts of our source code and do like commonly used bits of functionality while working with Kubernetes Go code. We have etcd, which I'm curious why we have that. Kube API server, also curious why we have that in our controller manager. Okay, so it looks like we have most components of the Kubernetes control plane, and I'm assuming those are binaries. Let's check it out and see if we can execute like etcd, for instance. Yeah, that's etcd, last I checked. Okay, so we have Kubebuilder, which is the one I think we're going to be running most of, Kubebuilder gen, everybody's favorite command line tool, Kubectl, and we have a handful of other ones, and it looks like we have a little vendor tarball here, checked out locally as well. Hi, Mateus. Good to see you from Berlin. And real quick, let's check chat. Doesn't look like we have any major updates, so let's keep cruising along. Let's jump back in the docs and see what the docs have to say. Okay, so it looks like there's a getting started section, and then one of the links that I kind of skipped over earlier when we were doing this week in Kubernetes is the Kubebuilder folks actually have this really cool Kubebuilder book. And the book is actually like a bit of online documentation. And we're going to see an easy way to generate documentation like this using Kubebuilder a little bit later on. Listen, Jason Tiberius says Kubebuilder sets tests such that they run against a locally running control plane. So that makes sense. Okay, so that's why we have etcd and the controller manager and the API server running so that we can easily test our code that we're generating using Kubebuilder. That's pretty cool. So I explored this a little bit earlier, and the one thing that I started to go through was I think it was installation and setup. No, it was this quick start guide here. Yeah, this is the one I went to. Let me add this to our repo really quick so that folks at home can, yeah, that's my like getting ready for the weekend wallpaper there. So that folks at home can find this if needed. And again, I'm going to cheat and edit this file directly. Don't tell anyone. Reference links, this one in review. Let's do, I'm just going to do a smaller title here. Documentation used in the episode. And let's add a link. Bam. Jason says no one's pronounced kubectl. So actually, speaking of kubectl, I was thinking how much fun it would actually be to write a command line tool and call it verbatim kubectl, just to like mess with people and make it like do like something else, maybe an abstraction layer on top of Kubectl or something, just to like really just grind in the troll there a little bit. But anyway, that's just me being evil. You don't really have to do that. So anyway, there is the quick start guide for folks at home. Let me go ahead and commit this. And if you want to follow along, file cannot be edited. I bet somebody came in. Oh, is it here? I think I have another browser up. Anyway, I can add it after the episode. So anyway, coming back to the quick start guide, this is going to create a project, create an API, and run an API. And to give you an idea of what we have going on here, I have a Heptio quick start cluster, which this is the second time I've deployed a quick start cluster. Usually I use Kubecorn, but I like to kind of just mix it up just to kind of like sanity check that everything is like working as expected and see if there's any big major differences between either of the clusters that you can deploy. I want to do a COPS cluster soon because it's been so long since I've actually deployed a COPS cluster in AWS to see what's actually going on under the covers there as well. But anyway, we can just do a quick kgit now. Everybody knows I alias k to Kubebuilder, and we can see that I am running in US West 2 in Amazon. I've got a handful of nodes up and running. And let's just go ahead and see what namespaces we have. Kgit namespaces. Perfect. Kube public, kube system, and default. And I bet if we check pods, there should be no pods running. Okay, so this is a pretty bare bones cluster that we have here. David said that's a sadistic thought, Kris. George says, I'm taking notes offline and we'll push to the repo. You can just keep going. Awesome. Thanks for helping out, George. That explains why I couldn't edit it. Joe Thompson says, it was officially announced at KubeCon. It's canonically kube control. Well, I think Brian Grant says he created the tool, or at least like architected the tool, and he says CTL. And that's where cubic ORN came from, which was forcing people to explicitly say the last 3 letters of the command line tool. But I think the truth of the matter is the world will never know how to pronounce KUBECTL. Okay, so back to our Kubernetes cluster here. We don't have very much running. Back to our quick start. Wham kablam. Oh, I said it. I always say it. I tell myself I'm not going to say it. Then I always end up saying it. Installation. Install dep. Okay, so this is already starting to look familiar to the operator framework episode we did a couple of weeks ago when we created a Kubernetes controller as well, which it looked like it just vendored in, not vendored in dep, but shelled out to dep from the Go binary. So I'm willing to bet if we look at the code behind Kubebuilder, it's doing the same thing as well. Let's go ahead and check and make sure dep is installed, and it is, and I think I can do dep version, I want to say. Yep, and that's going to tell us that we're running 0.4.1. So we have dep installed, so that looks good. Next it says download the latest release from the releases page. We just did that and checked out the directory, and extract the tar, and move and rename the extracted directory to user local Kubebuilder. Okay, and it looks like here on the right is step-by-step instructions on how to do that. So here's the curl command to download the tarball that we downloaded from GitHub. Here's our tar command to untar it. And then it looks like we move that to user local Kubebuilder, and then we update our path here at the bottom. So I've already done a little bit of that when I was preloading Kubebuilder before we started the episode. So if we go to user local Kubebuilder, here we can see Ben. And here's everything we downloaded that should be in the Go source. Let's just compare really quick. GitHub.com, Heptio, TGIK, episodes, 40, Kubebuilder, Ben. Wow. Okay, and those look the same. And now let's check out path. So echo my path out. I hope I don't have anything vulnerable in here. I shouldn't. No, it should just be all path information. And then here at the end we have user local Kubebuilder Ben. So now, just to do a quick sanity check, let's go to my home directory. Another quick Unix one-liner for folks at home who don't know. CD with no arguments brings you to whatever you have defined in your home directory. So you don't even have to do that. You can just do that and save those oh so precious extra 2 keystrokes in case you're wondering. So anyway, from here, I should be able to execute everything in my path. So I should be able to run Kubebuilder, and poof, the binary executes. Okay, but it yells at us, and it says, okay, Kubebuilder must be run from the project root under GoPath source package. Current GoPath, users Nova Go. Current directory, users Nova. So it's yelling at us that we're not in our GoPath. So let's go to home directory, go source, github.com, Heptio, TGIK. Let's try to run it again, Kubebuilder. And I'm gonna mute myself really quick because I keep getting those audible bells. How do I do sound preferences? Output, mute. Let's see if that does it. That way, at least I'm not going to be blowing you guys up with my audible bells the entire time. So anyway, I should be able to hit Kubebuilder now. And poof, now that we're going to go past, Kubebuilder executes. Okay, so that's installing Kubebuilder. Now, let's create a new API. So the first thing we want to do is we want to create a project. Kubebuilder init domain, kates.io. And then real quick, because I want to kind of jump ahead a little bit here, in a second, we're going to create a resource. And in this example, they use group ships. but I would like to do something other than ships so that we can easily create this new idea that's relevant to TGIK. I used the operator framework live on stage at GopherCon EU in Iceland, and there we created a puffin operator that actually ended up echoing out various ASCII puffins on the screen live on stage. So if anybody has any ideas for what we could create a resource on, feel free to drop them in chat now, and then when we get to this next step here in a moment, we should have some ideas. But anyway, coming back to creating a project. So the first thing we want to do is we want to do Kubebuilder init domain kates.io. And what I want to do is I want to create a new directory. Let me open up my terminal. In TGIK episodes 40 for us to do all of our work today. And then we're going to push that up after the episode, like I mentioned earlier. So here, let's do a make dir. We're going to call it live, and that will be like our working directory in our working directory where we can put all of our Go code and know that we can have a main function there. So going into live, and we should have nothing in here. And now we can run our Kubebuilder init command. Kubebuilder init -- domain kates.io. We all know my favorite domain. We're going to do fabulous.af, which is great, and I use this all the time for live demos. If you ever get a chance to check it out with me on stage, it's pretty fun. Okay, so let's see what's going on here. So the first thing it says initializing project structure. So it creates a CMD directory, which again, that's a common convention we see in Go, and especially in Kubernetes land, which is usually the entry points of the program. We have our PKG directory, which is where we're going to put all of our internal guts of the program, everything from the actual API definitions in the different versions, all the way to specific business logic or controller logic that we'll be writing downstream. And then the very last thing it does is it says updating vendor dependencies, running dep ensure. So here I bet we're shelling out to dep, and I bet if we did a check on my file system, we could see, actually, you know what, let's do this. Let's split, zoom out there. Oh, I already missed it. Okay, I was gonna actually see if we could find a dep process running at the same time, but it looks like dep has already exited. Okay, so let's readjust, bam, there and there, and let's scroll up and see what we have. It says updating vendor dependencies, running dep ensure, updated vendor dependencies successfully, and next define a resource with Kubebuilder create resource, which let's see if folks had an idea for a resource yet. If not, I might just do puffin again because I really like the Icelandic puffin, to be honest. Aaron says fabulous.afghanistan, which is true. That's where the AF suffix comes from. The Afghanistan country. They're not cheap, but if you ever get a chance to go check it out, you can actually find some pretty cool something.af domains there. Joe Thompson says another fun trick is CD-, which goes back to the directory you were last in, and that's in the POSIX definition of CD. I'm going to see your CD- and raise you one more, Joe. So here, if we do list, and we can do change directory back and list again, you'll see we're flipping back and forth between our two directories like Joe just said. Now check this out. If we clear and we do git checkout new branch, example branch, we can do git branch and run example branch, and I can do git checkout minus, and it goes back to the branch I was just previously on, which is pretty cool because now we're back on the Kubebuilder branch. So Git and a lot of other programs also respect the minus command that a lot of folks don't know as well. So that's like your Kris Nova pro tip of the day, git checkout minus. Cool, so we have another comment in chat here. It says, need help, 2018-06, Kubebuilder must be run under the project root go path. So I think how we were able to solve that, again, I'm really sorry if I mess up the pronouncing your name, Abdenor, was you navigate to your go path on your local file system. So we were able to navigate into our go path and actually get the Kubebuilder binary up and running. So let us know if going into your go path is going to work for you. Okay, cool. Real quick, let me grab some Diet Coke. Okay, let's see, Aaron says, it's Go's helpful build runtime that doesn't work like any other tool set ever. You have to do everything related under go path. Yeah, and then if you're curious what your go path is, you can actually do an echo go path, and it'll actually tell you where it is. And another interesting nuance to Go that a lot of folks don't know is you can actually set your go path to more than one directory. You can actually do like an export go path is equal to your old go path, colon delimited, and then, like some other, if we had root directory go, but you see this in containers a lot, we now can check out, or we can echo out our go path and actually have more than one go path that we could work in. So if we went to /go, which do I have? Nope. Make dir /go, sudo bang bang, and go into /go, and let me sudo bash really quick. Now I bet I can run Kubebuilder as well. Oh, it's not in my path, but if I did user local Kubebuilder bin Kubebuilder, I bet it won't yell at me. Oh, it's because I lost my go path here. So let's do export. It's because I came up to root. Let's try this now. Kubebuilder. I lost it. What happened here? I'm in /go. I probably lost my export, so anyway, I'm going off in the weeds here. Okay, let's go back to our directory. Go, source, github.com, Heptio, TGIK. I'm going to be so good at typing this by the end of the episode. Episode 40. And then we want to go to live. All right, cool. All right, so back to our documentation. Okay, so we've created our project. Now we want to create our API. So we're going to do Kubebuilder create resource, group ships version v1 beta 1, and kind is equal to sloop. And we might do kind is equal to puffin. We'll see. So the kind, this is, again, we talked about this a little bit in the operator framework. This is just an arbitrary idea that's important to you and your organization and building whatever API you want to build. So Kubernetes APIs are super handy, and I guess I could rant a little bit here about why we're even doing this and why Kubebuilder is even relevant. But we're creating a CRD and then ultimately running a controller, just using a different tool chain with different paradigms than the operator framework that we did recently. And in this case, we're defining a new arbitrary idea that's important to humans, and we're going to write some sort of reconciliation loop to go and actually respect that. So in this case, we're going to do group is equal to birds, because we're going to have a kind puffin. So let's do birds. And version is equal to v1 beta 1, and kind is equal to puffin. Yeah, Olav got it as well. So yeah, let's go ahead and execute that. Bam, Kubebuilder must be inside your project's root. I bet I messed up my go path. Let's do export go path is equal to users Nova go. Let's try this again. Cool. Okay, so either the way that Kubebuilder is parsing go path or the syntax I just prescribed is no longer valid in the Go programming language. One of those two things is going on. So I reset my go path, reran it, and now we're back. Okay, so let's see what happened here. We have creating API files for you to edit. We have edit your API schema. So it's created some Go files for us here. It created our controller for us. That's pretty rad. And we can go in and we can edit our controller function. So package controller puffin controller.go. And we have a controller test, which is really handy. So already we're starting to see like we're generating tests. We're taking this to the next level, and we're getting a lot of the boilerplate taken out of us, or taken care of us as we start to define APIs and write controllers for them in Kubernetes. And then we have this hack sample puffin.yaml. We all know how much we love looking at YAML, so we should totally go check that file out. And it says generating code for new resource. Regenerate after editing resources files by running Kubebuilder build generate. Okay, cool. So I think what's happening there is it's actually going to read our Go file and then generate our YAML for us. So we can do this Kubebuilder build generate command here to regenerate that YAML as we make changes to our underlying software. It says next, install the API, run the controller, and create an instance with this command here. And then we get to kubectl apply hack sample puffin.yaml. Okay, so that's what we just did when we created our resource. Let's go and start poking around the directory here and actually see some of these files and start looking at some of these files that Kubebuilder just created for us. So let's open up my IDE. We're here in episode 40. So here's our Kubebuilder tarball that we untarred earlier. Here's the actual tarball itself. Here's our live directory, and then everything in here that's kind of a funny color is something that we just generated with Kubebuilder. So we have our go package.lock and our go package.toml that was created so that we could use dep. Looks like we have a Docker file here. Let's see what's going on in this Docker file. Ooh, this looks big. So we pull Golang.1.9.3, which is a pretty new copy of Go. We define some environmental variables. We download some test framework binaries. We mark a few things executable, the API server, Kubebuilder. We copy in the Go work directory. So we're saying that we want our work directory, which is episode 40 live, to be our working directory in the container when we create the container. And then it's copying over package command and vendor so that our code can run. And it says build and test the API. So it says run cgo enable equals 0, goose equals Linux, gorch equals AMD 64. So this is the proper way of saying these two environmental variables. It's goose and gorch. Rob Pike has a YouTube video on this if you actually want to go and check it out. But goose and gorch are handy because the Go compiler will cross-compile for you automatically out of the box, which means running on Darwin, I could go and potentially create a Linux binary just by setting goose equal to Linux and gorch equals to AMD 64, which is pretty handy because from a single computer, you no longer need to like compile on a container or compile on a virtual machine or go over to a different computer and compile. You can cross-compile right here locally on your own machine using goose and gorch. So Felipe Martin says, what is the meaning of these hack directories in Kate's projects? Which is really handy. Oh, you got me wine?
Yes.
Okay, so Joe, for a present, got me, this is really exciting, some rainbow house wine. So I'll probably wait and celebrate after TGIK for my house wine here. So thanks, Joe, for my rainbow canned wine. I'm live on TGIK. So anyway, goose and gorch is handy. We do a go build, we check out the controller manager, and then we run main.go. We copied the controller manager into a stem image, which is now running in Ubuntu. So this is a pattern that you see commonly in Docker files now that allow you to build using this Golang container and then actually stick everything in this thin container afterwards and actually generate your image here while building everything in the container above it, which is pretty handy. And then we just copy it, and then we actually run the controller manager right here. So that's our Docker file. So let's see what else we got, and then I want to answer the question about the hack directory in 1 second. Okay, so Felipe says, what is the meaning of these hack directories in Kate's projects? So let's actually go and look at some of these, and I can try to answer them, because I think they kind of mean a lot of different things to a lot of different folks. So the first project I want to pick on is Kubernetes Kops, because I wrote a lot of these files, so I feel like it's safe for me to pick on them. So if you come in here into Kubernetes Kops, we have a hack directory, and these are all shell scripts. So these are just miscellaneous chore scripts that we would use in Kubernetes for everything from building a binary to deploying it to Kubernetes to maybe like running some sort of integration test or E2E test, or even just like validate that like before somebody tried to push a commit that all the headers are actually there. So again, these are just like common chores for software engineers. If we actually go and we look at Kubernetes, the hack directory here, oh, I did Kubernetes. Oh, okay, we're here in the hack directory now. That was cool how that just worked. You can sort of see it's even more busy chore shell scripts. Everything from validation to verify Go imports to verify Go funct that just, again, make it easier for software engineers to manage and work out of the repository here. Another thing that you'll see in the case of our, let's go back to our IDE, is you'll actually see different bits of YAML here. So this is the first bit of YAML that I said we were going to look at. But this is actually what's going to be encapsulating our project that we're working on and then later getting deployed to Kubernetes. So TLDR, hack is for whatever you want it to be. You can use it for anything, and it's kind of a hacky directory, which is why it gets called hacked, and I think, or it gets called hack. And I think if you want to drop a hack directory in your project, that's sort of like I look at it as like the junk drawer. Just like throw anything you want to in there and use it for anything you want to. Okay. So Joe says, hack directories was something I added to the early Kates repo and a set of scripts. I think we borrowed it from Docker at the time, and now it's just totally like YOLO, drop anything in the hack directory and call it a day. But here we see sample/puffin.yaml. So without further ado, let's look at some YAML. Oh, this is really anticlimactic, but still really powerful. Okay, so all this is actually just defining a single instance of a Puffin custom resource. So we say the API version is birds.fabulous.af, version 1 beta 1. It's of type Puffin or of kind Puffin. We give it a metadata name, and we say the spec is equal to foobar, which we're going to define all the different various foobar key value pairs we want to for a Puffin downstream and actually reconcile that and read off of that moving forward. Cool. Felipe says, cool, thanks for the explanation. And Abdanor says, great, you're using multi-stage Docker files. So again, this is just, Kubebuilder did everything for us. This is just me exploring the directory that Kubebuilder already created. So yeah, here's our sample puffin.yaml. And I bet we could come in and we could actually create a new copy. We'll say puffin2.yaml, and we'll give puffin2.yaml, what did we call it? When we were in Iceland, Francesc had the best name for a puffin ever. And I want to use the name. I can't remember what he said. Oh. He said we should name a puffin muffin, so we have Muffin the Puffin. So thanks, Francesc, for naming our puffin here several weeks later on TGIK. So now we have 2 puffins we can play with as we start to build out a controller, which will be handy because we'll be able to deploy them and mutate them independently of each other. Okay, so let's go back to our documentation. We've created our resource. We said it's of group birds of type Puffin. And let's see what the docs say here. It says, optional, edit the schema or reconcile business logic in the package APIs and package controller, respectively. Then run Kubebuilder generate. And then you can read what is a controller and what is a resource, which we've kind of defined those loosely. And if folks have questions, just feel free to ask in chat, and I can draw a picture if needed. So I want to run this Kubebuilder generate command and just see what goes on here. So there's Kubebuilder generate. Let's clear my screen. And I wonder if there's like a verbose mode because it's not spitting anything out right now. This is why I always think logs are important, because whenever a program takes a while and like doesn't do anything, is there no verbose mode? No, there's not. I always wonder like, what would you do behind the scenes there? So Aaron says, if you have time later, could you speak as to when it's appropriate to create a new Kubernetes custom resource type? Aaron says, please. Yeah, so creating a new Kubernetes custom resource. I think for me, to answer that question, like what I would do, every time I want to define something in Kubernetes that goes above and beyond a simple deployment, in other words, like just installing a container, just running a container or just routing traffic to a container isn't enough. I need to take some sort of other action. Like I need to be able to declare something or ultimately want this to be responsible for managing something. That's when I start saying to myself, I wonder if a CR and a CRD is going to make sense here. So again, the TLDR, when simply deploying is not enough, is when I start to scratch my head wondering if it's time to write a controller or an operator. And then again, I'm going to quote Joe, a controller is a very specific declarative piece of software that reconciles state, and an operator is just a domain-specific controller. It's just a controller that is very specific to doing one thing and doing it well. Okay. So Aaron says that's what's going on here from what I understand. Yeah, so anyway, back to our docs. I don't know what Kubebuilder generate did, but I think we're going to run it later after we mutate something, so maybe we just need to make a change, and then we'll see some output there. Okay, so back to our documentation. We want to add some business logic. Okay, so it looks like the docs here say, oh, well, clearly they tell us to open it in Nano, so we're going to have to do that live on TGIK. Nano -w, package APIs, ship, sloop types.go. I'm not going to open it in Nano. I'm going to use my IDE here. But we want to open up sloop types.go. So let's see. That's going to be in package, APIs, birds, v1, beta 1. Oh, and it's not sloop because we renamed it to puffin. So we want puffin types.go. And if you look at the way the directory is structured here, we have all of our different APIs. So we could do create different projects and resources, one of which called birds. We could do another one called dogs. We could do one called mountains. And then we could have different instances inside. So in this case, we have puffin. So this is like the core of our app. Edit this file in all caps at the top. So this is where we're going to come in and define command P. Abdemnor, what are you trying to suggest I do with Command P? Is the font not big enough, maybe? Let me know the desired outcome here, and then I'll see if Command P is the right command to use. And then Suresh says, what is a trade-off between operator framework and Kubebuilder for creating a controller? When to use which circumstance? So we're still learning a little bit about Kubebuilder, but I'll try to answer that question a little concretely because I did notice some differences along the way, and we're going to kind of discover them as we go through actually deploying one of these controllers to Kubernetes. But the TLDR is the operator framework is very specific to writing an operator, whereas the Kubebuilder framework is a little broader scope. It says you can create a controller, and then from that controller, you can sort of make that do whatever you want. So like you could totally build an operator with this, but this is a little closer to using raw Kubernetes code, whereas the operator framework actually gave us this SDK abstraction layer on top of the raw Kubernetes libraries to make writing a controller or to writing an operator easier. So Kubebuilder is going to be a little closer to the core of Kubernetes, and the operator framework is going to kind of be a layer above with this like abstraction that the folks at CoreOS Red Hat put called the operator framework SDK that they put between you, the software engineer, and the internal Kubernetes libraries. So it's a matter of convenience versus functionality. So you're sort of exchanging one for the other there. So anyway, I hope that explains what's going on. So here we have our Puffin spec. Insert additional spec fields, desired state of the cluster. And then here, yep, this was what I was expecting. Run Kubebuilder generate to regenerate code after modifying this file. So it looks like we have the same thing going on down here in Puffin status. And it says, again, run Kubebuilder generate after we update our status. So let's do status first. And let's say we have a message, and we'll call that a string. And then here in the Puffin spec, we're going to do, we'll have different colored puffins. So we'll say color is also equal to a string. And then I think we need to define this JSON here, or we're going to run into problems downstream. So let's actually we'll copy this one and tweak it real quick for color and for message. So here we want to say color, which is lowercase, and here we want to say message, also lowercase. And then of course, if those aren't there, we want to omit them from the JSON, so that's what this omit empty is doing for us here. And then down here at the bottom, the very last struct we have defined is a Puffin struct with a reference to a Puffin spec and a Puffin status. And you'll see this pattern all over Kubernetes, that we have a spec and a status. Those are two very important parts of defining a Kubernetes object. Here they are defined in Go. Most folks usually see them in YAML. And here above, we can define spec and status. And again, we can put anything we want in here that's going to be important to us and our business or our use case. So like to take a cluster API example, we would have a cluster spec or a machine spec. And in the case of a machine spec, we would have all of these directives here in our Go struct that define everything that we would want to define in a machine. So for the cluster API, we would have things like operating system version or operating system type or the size of the machine or maybe its IP address or like all of these wonderful configuration bits that would define what a machine is. In the case of our example here, we're just doing Puffin and we're giving it a color just to have a quick demo. And then of course for our Puffin status, we have message, which will just be some message about what our controller has done behind the scenes. Cool, so let's go. And let's now run our Kubebuilder generate and regenerate these docs because we've mutated our spec and our status here. So Kubebuilder generate. Again, the dreaded silent wait command. What's happening? I should have done a git commit so I could see what changed. But I bet if we go into hack, actually let's do this in my IDE. I bet if we go into the hack directory and we look at our sample, nope, that hasn't changed. Let's go back to the docs and see what's going on here. Okay, so it says to edit our types and then also to edit our controllers. So maybe the Kubebuilder generate is expecting us to edit both before it actually mutates anything. So let's go see if we can edit the controller as well. So that's going to be down here in package, controller, Puffin, controller.go. So let's see what this thing has to say. Again, at the top, we notice this giant edit this file. This file was created by Kubebuilder, create resource for you to edit. Controller implementation logic for Puffin resources, go here. This is already getting exciting. So here we have a method, and if you remember, we learned about functions and methods when we did the operator framework, TGIK, and a method is just simply a function that is attached to some data structure, and it's usually a pointer to that data structure, and then usually a method is going to mutate whatever you have the whatever data structure it's attached to. So right now it's not really doing that, so it's kind of breaking idiomacy, but we can definitely change that moving forward. And in here it says insert your code here, which is where I think it wants us to take action and make some sort of mutation. And it looks like we do a real quick log printf, implement the reconcile function on Puffin controller to reconcile, and then it passes in our name here and it returns no. And then we have a controller struct. Okay, so we saw a very similar pattern in the operator framework a couple weeks ago that said that we had, it was called a handler, but now we have a reconcile. But regardless, both were attached to this sort of arbitrary struct that we could do whatever we want. So like here, maybe we could have a directive that we'll call status bit, and actually we'll just do status. I'm trying to think how I want to do this. Let's just do this. We'll do this logged, and we'll set that to a bool. And what this is going to do is after we log something, we will flip this bit. So this is going to sort of act as an internal cache for our controller as it's sort of reading and dynamically pulling configuration from CRs as it's running up in Kubernetes. So we can use that here, and we can do if BC logged, if not BC logged. So the way Go works is if you don't set it a Boolean value, it defaults to false. So by the default case here will be we'll trigger this if statement, and we're going to say if BC logged. We're going to move this up here. We'll log it, and then we want to flip our bit. So we'll say BC logged is equal to true. Cool, and that means we should only log once there. And did I lose my log statement? My log import? I think I did. Let's see what we can do here. Let's undo some of this and go back to where we were, because I don't know what logger they were importing. So we'll copy paste, and then we'll come down and Control K, delete that. There we go. That looks a little bit better. And we can do BC logged is equal to true, and come over here and tab this over. So again, we now have our controller cache in memory that we can define whatever we want, and we can use that here in our reconcile function to reconcile that as needed. Okay, so we've made a mutation as the docs have instructed us to. Let's run our generate command again. Oh, great, we got some output now. Okay. Could not read package APIs directory to find API versions. Go routine. Am I not? I bet it's because I'm not in the right directory. Let's try this again. Yeah. Okay, so that would be my first bit of feedback for the Kubebuilder folks, which is we totally threw a panic. We had a go routine crash just because we were in the wrong directory. So maybe a little bit of a validation check at Bootstrap as we enter the main function and as runtime kicks off for the program would be helpful there. So anyway, we ran Kubebuilder generate. Let's go see what the docs say to do next. We did that, and it says publishing. So it says integration testing. Run the generated integration test for your API. So go test package. And again, this looks like it's going to assume that we're running in the top level directory here. I don't know if it says that anywhere here in the docs, but that might be wise to say and also have the program remind us in case something goes wrong along the way. So anyway, back in the top level directory, we're going to run go test package and see what happens. So these are just regular Go tests. Interesting. And it looks like my CPU, and my fans just turned on for my CPU because the Go compiler just really started warming up. So we're going to let this go and compile. I'm going to grab some Diet Coke and maybe some of my rainbow wine here while we wait for our tests to run. Happy Pride, everybody. So this is the integration test for your APIs, and I actually haven't ran this yet. Okay, so that wasn't too horrible. I was expecting that to take a little bit longer. But it looks like we have normal output of go test here. It'll let us know if it ran okay, and then if you see a question mark, that just means that it recursively checked out a package, did not find any test files, and just moved on. So anytime you see okay, that says, yes, we found test files, yes, we tested them, everything's okay. And every time you see something other than okay or a question mark, that's usually a sign that something went wrong. And if we actually check the exit of our the exit code of our previous command here, it exited 0, which means yes, our tests have passed. So go back to our documentation. So we were able to run our go test package, everything passed, and it says now let's actually go and publish this and run it in Kubernetes, the exciting part. Aaron, happy Pride Week. Thanks, Aaron. I wore my really nice plaid just for Pride this week. So anyway, we have docker build command. So let's see what we have here. It says docker build -f, the name of the Docker file, -t, a tag, and let's go ahead and build ourselves a Docker image. So come in here. Oop, that's not. I'm going to cancel that because that's not going to work. I accidentally got my new line at the end of that command, and then, of course, Unix picked up that new line and executed my command. But we're going to change that a little bit first. Okay, so we want to build our Docker file .controller, so that looks good. And now let's actually call this something else. Let's call this my Docker Hub username, which is Kris Nova. And we're going to do Kubebuilder example. I already have a Puffin controller, so we can't use Puffin controller again. And then we'll just do latest. Why not? That looks good to me. So this should build a Docker image for us. Let's see what happens. Sending build context to Docker daemon. And then now it's running that Docker file we looked at earlier. You see a lot of these commands that we looked at earlier in our Docker file are running now, and we're building our container image. So while we wait for that, let's go see what's next. Kubebuilder create config, controller image, and then it looks like you pass in the name of the controller and the name kubeships. So I bet I know what's happening here. I bet Kubebuilder create config is going to actually go in and create our YAML for us to deploy our newly created controller to Kubernetes. Waiting on our Docker image. I really want to run this command because this is going to be exciting because it's going to generate YAML. This is the wine. It's already kicking in. Let's see, can I split my screen and zoom in on this one? Okay, so while we're doing that, let's get our next command ready here. So go source github.com Heptio TGIK episodes 40 and go into live. Okay, so now we can get our command here on the right while we're waiting for our Docker image, which is Kubebuilder create config controller image. Let's name this, rename this rather, to what we just called our image we're building. So that was Kris Nova / Kubebuilder example tag latest name kubeships. We'll call it kubebirds. Why not? So I bet this name is going to translate to a namespace or something downstream when we actually generate the YAML we're going to deploy to Kubernetes. But I don't think the code should assume that the image is on the local file system. I think this is just going to generate YAML with what we name it. So I bet this is safe to run while we're waiting for our Docker image to build over here on the left side. So let's go ahead and run this. Yep, sure enough it worked, and it looks like our Docker image is done as well. So it says config written to hack install.yaml. So here again we see hack being used for hacky things, and I bet if we go look at install.yaml, we're going to start to see Kubernetes resources defined in our YAML file. And let's open that up. This is hard because I'm like zoomed in here. So we want to go to hack, install.yaml, yay. What wouldn't be TGIK if we weren't looking at Kubernetes YAML and talking about it. Okay, so the first thing we have is we have a namespace, and my assumption was correct. We are actually calling it the kubebirds namespace, but it looks like we're prefixing that or suffixing that with system here. So we now have a new system namespace called Kubebuilder. We're creating a cluster role that's open to the API group that our API is defined in, and we're opening up all resources and all verbs to the default namespace here. And then we have a cluster role binding that's going to map to our service account. And then we have our CRD defined in here as well. Okay, so this is different than the operator framework. So this puts all of the resources into one, and then I think you can just run this generate command and it'll re-update this as needed. Whereas the operator framework pull all of its YAML apart into different manifests is what they called it. So again, we're seeing sort of these same concepts in Kubernetes defined and ran in different ways. So to one person, it's called a manifest. To somebody else, it's a hack install YAML. Ultimately, they're all Kubernetes resources defined. So interesting paradigms to see how different engineers solve the same problem. So here in our CRD, we have a name. We have our spec. We define the kind is equal to puffin. We have more than one puffin is plural puffins. Although I'm curious if that's true. Do you have a flock of puffins or do you have a flock of puffin? Is it like sheep and fish? So the scope is namespaced. We define some validation for our CRD, which is pretty handy. This is a really cool paradigm for folks who are interested in really like mastering CRDs and CRs in Kubernetes. You can actually define like required directives and required fields and actually validate the CR that somebody's pushing up for your CRD actually meets an arbitrary set of rules. So you're actually to almost basically, you're given an opportunity to define a schema for your CRD. I don't think we saw this in the operator framework. So this is cool to see that this is defined here in Kubebuilder and gives us a starting place where we can start to validate our CRs as they come through. Last, we have a Kubernetes service, which again, this is just like a network layer on top of some sort of deployment or stateful set or something. And it's going to tell us labels that we can map to for various other primitives downstream. And last but not least, we have, this is interesting, we have a stateful set. The stateful set, I bet if we find our containers, yep, here it is. So this is what I typed in the command line earlier, was probably pushed down and populated here for the image. Now I'm curious why we're using a stateful set for our controller here. I would want to know what was the idea that we had in mind when we said we're going to create a stateful set instead of a deployment. Which they're fairly similar. I mean, you can deploy a container with both a stateful set or a deployment. There's just some different paradigms about how they're scaled and the guarantees about where the containers are going to be ran, which nodes are running which pods, and how those pods are named. So curious why stateful set was picked here. So anyway, that looks good. Spec replicas is equal to 1. So yeah, this is going to create a single pod with a single container running as a stateful set in Kubernetes with some RBAC rules, with a service, in a new namespace called Kubebuilder system. And I bet if we go to our docs, yep, it says let's push up our image, and then we can do a kubectl apply. So let's copy our docker push command. Oops, sorry, I got my new line again. Docker push. We'll do Kris Nova /Kubebuilder example :latest. Cool. So that's pushing up. Aaron brought up a really great point in chat that says there's no PBCs used here. Yeah, I don't think you have to use a persistent volume or a persistent volume claim while you're using a stateful set. I think you just see that a lot because stateful sets were sort of engineered to make managing state with persistent volumes and PBCs easier. But I don't think it's a hard requirement that you have to use one. So again, that sort of alludes to like this question of why did we pick stateful set? I'm wondering if there is a technical reason that we're maybe missing out on. So that might be something interesting we can follow up with the API machinery folks on. Aaron says it's probably just shortcuts to stateful set to simplify the case where a controller needs a PBC. Very, very reasonable explanation there. So good observation, everyone. Okay, so we were able to push up our Docker image. And now let's go ahead and run this apply and see what's going on in Kubernetes. Okay, so we're here in our top level directory. Let's make sure this is what the docs tell us to do next. Yep. Copy this. Paste here. Perfect. Okay, so we created our namespace. We created a cluster role binding. a CRD, we created a service, and a stateful set. And this is all in the Kubebuilder system. So let's do KB. I learned this one from Joe watching a TGIK a couple months ago. KB is equal to Kubebuilder minus n Kubebuilder system. And let's throw this in double quotes. So now I should be able to KB get PO. Bam. Okay, that was cool. So Kubebuilder controller manager, and I bet we can get logs for that doing, let's do KB logs and copy the name of our pod here. Oh, do I need a space? Yeah. No logs. What's going on? Huh. I wonder if there's something going on with the cache that I implemented earlier, but we should be able to see some logs pop out as oh, you know what I bet's happening? I bet it's because we haven't created a CR. Let's see if we have any CRs for our CRDs. So to list our CRDs, which is the schema basically, we can do KB get CRD, and then I bet we can do KB get puffins. No resources found. Okay, so let's go back, and remember earlier we defined 2 puffins. Let's look in our hack directory here. We have sample and we have puffin.yaml. So let's apply that puffin and let's check our logs at the same time and see if we can get like a side-by-side going on here. So we'll do our logs on our pod here on the left side, and actually we'll clear that. Now we have some logs and we'll throw in some black space there. And then over here we can do kapply minus f hack, what was it? It was sample puffin.yaml. Bam. All right, so we created a CR, and our controller loop that we just defined, we just wrote this live on TGIK, was able to actually go and log this this file for us. Or not this file, but this string for us. And then I bet if we ran puffin2, it should not, well, it has the same name, so I'm curious how this is going to work. It may or may not actually log a second line. Let's see what happens here. Okay, cool. Wait, no, it didn't deploy. The puffin muffin is invalid. Oh, because it's capital. Derp, derp, derp. Sorry, we can't name a puffin with a capital muffin. Let's try this again. And this will be cool because this will demonstrate our cache. Okay, so now if we do kget, let's do it over here where we have kb define. Kb get puffins. We have muffin and we have puffin example. We have 2 of those defined, but if we look at our logs, we only logged once. So this is a great example of how we were actually able to come in here in our controller code in controller.go, and we were able to say BC logged. So now this is demonstrating that we can make all kinds of interesting things happen in Go, and we can flip bits, and we can have logic, or we can hit other APIs, or we could like do other things in Kubernetes, and we could change the behavior of our controller. Also, Kubebuilder gives us this really great opportunity to come in and define the various spec and statuses that we're updating. So let's see if we can redeploy this, and this time updating our status along the way. And this is what we did with the operator framework a few weeks ago as well. So this way you're kind of getting like an apples to apples comparison of the 2. So let's go back to our docs, and then this will be the last thing we do, but you can actually generate the documentation with Kubebuilder, and we can actually pull up like what looks like the Swagger generated docs for our API. But let's see if we can update our status first. I wonder how we're going to do that. Simple controller example. So let's just grep for status. Nothing. Controller watch functions, creating events. Do we see status anywhere in here? This might be like episode 2, because this is looking pretty noisy. There's a lot going on here. So we can watching controller resources, which I think we're already doing. We can watch created resources, arbitrary resources. So yeah, these are just all different ways we can change the behavior of our controller based on our CR and CRD here. And then real quick, well, 2 things. First one is Olav confirms puffins is the correct plural for puffin. And Jason says you could add -- controller type equal to deployment, and it gives you a deployment rather than a stateful set. That's good to know. Interesting though still that it defaults to stateful set. It's not what I would have expected out of the box. So curious behavior here. And again, we're just seeing differences between two frameworks that are sort of relatively doing the same thing, which is helping us get CRs and CRDs and controllers or operators up and running in Kubernetes. So let's see here. Let's go back to our hello world and let's see. Oop, not stackoverflow.com. Nope, we want status. Okay, well, it's not shown here. Most resources will split their fields into a spec and status. Let's see what this pancake controller is doing. So here in reconcile, we take our pancake client and we call get. I bet we can do this and do an update. Let's see. I don't know what's going on with this error though. I'm gonna pull this over to the side so you guys won't be able to see this and see if we can't live code and use my IDE to help us out here. Okay, so I bet we can do BC. Is there a client here? A Puffin's client. And then we want to do Puffin's k.namespace. And then I'm curious to see what functions we have here because I bet this is going to be like our goodie box here. Yep, so here we can do an update. Awesome, and then we want to pass in I think a Puffin is what this thing takes. Let's go look and see. Update, and it takes a v1 beta 1 Puffin. Okay, cool. So let's go back to our controller. And do we have a Puffin here in memory? I wonder how we would, do we have to get it first? Yeah, let's do this. Let's get our Puffin, and then we'll update it. Get. So the name here is going to be k.name, and we're going to do v1 get options. Cool. Okay, so then we're going to say Puffin is equal to this. Does it also return an error? I bet it does. We'll just log an error. Printf error. Do v, and we'll give it a new line at the end. Okay, so all I'm doing now is I'm trying to get a Puffin in memory so that we can update a status and we can actually show that we're operating on both of the Puffins we have created. So hopefully we can do this now. bc.puffinclient.puffins k.namespace.update. And then we're going to pass in our Puffin here. And we're going to say puffin.status.message is equal to we operated on this Puffin, and we'll say the name of our Puffin. Actually, we'll say the color of our Puffin. So we want to do a sprintf here. Cool. So this should let us demonstrate that we can actually take action on arbitrary CRs that are defined in our Kubernetes cluster using Kubebuilder here. So here we want to do puffin.spec.color. Cool. Puffin status message, bam, 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 and then we update it. Okay, so we're going to get the specific Puffin that we're operating on, and then we're going to update its status and print its color. So now let's do Kubebuilder. Let's do a Kubebuilder generate and then a push. I think we need to do a generate again. Let's just run it for good measure. And where did I run those Docker commands earlier? Okay, so here's my Docker build. So we can get this one queued up. Control R, Docker build. Okay, so we're going to push a new image up to our Docker Hub registry, and then we'll redeploy that image by killing the pod. Let's check the YAML and make sure this is going to work. Usually the way I do this is I kill the pod, and the Kubernetes scheduler will redeploy the pod with the image pull policy set to equal to always, but I don't know if that's the case here. So let's go see and find out. So how we're going to check is we're going to come check our install.yaml that we created earlier, and I bet we can search for pull policy. Does not define it. It does not define it, so we're going to run it and see what happens. I think stateful sets are going to default to always, but good question. Okay, so back here, let's go to our docs while we're waiting for this and get ready for the last thing I wanted to show you. all moving forward, which was generating our documentation. Sorry, trying to talk and pull up docs here at the same time. Okay, so we want the book. There's a book here, and then we did quick start, and then bam. So this is what the last command we're going to run is as soon as we redeploy our Puffin controller here. So let's get our pod command ready. Kget po. Actually, we'll do kget po, and we'll do a kb delete po. Bam. And because this is a stateful set, it should recreate it. I don't know with or without a new image, if it's going to repull or not, but we'll see. Here on the same node. With deployments, it'll automatically, by default, spin it up on a new node. With stateful sets, it'll stay on the same node. So that's the behavior that we should expect to see here because we're running a stateful set instead of a deployment. And we're still waiting on our Docker build, which I guess real quick, I can just do a quick compare of the operator framework build time versus the Kubebuilder framework build time, which was I was able to, I think, push 3 or 4 Docker images live on stage within like 35 minutes in Iceland, and this has taken pretty long to do here on TGIK. But anyway, Jason says, from the Kubernetes docs, stateful set is used by default to ensure that only one instance is running. Okay, so anyway, that's pushed, so, or not pushed, but built rather, so now we can do our Docker push, Control R, Docker push, get that up and running. So that's pushed, layer already exists, we're almost done there. And now let's delete our PO and kb get PO. And we probably could watch this, but it's taking a while for it to terminate. Container creating. We could do describe on it, but it's still going to be called latest, so we're just going to have to check the behavior just to see what it's doing real quick. So anyway, we can do kb get PO, we'll get the name of it, and we'll check our logs here on the left. Implement the reconcile. Okay, so the logs look good. That's still the desired behavior based on the change we made. The real question is going to be if we do a kget puffins. Let's do OYAML. I bet we can grab before. Oh, right here. We operated on this puffin, but we did not define a color. So I bet if we check our YAML here in hack sample, puffin.yaml, yeah, we could do color is equal to blue. We'll name this puffin. I need a good name here. We'll name it after Charlie. We'll have a puffin called Charlie. And let's apply puffin.yaml and see if we can get our status to update and actually show the color of the puffin here. So we want to do k apply -f hack sample puffin.yaml. We should have puffins birds fabulous.f Charlie created. Kget puffins. Cool. And we have Charlie, which was created 7 seconds ago. And I bet if this is like the big drum roll moment. Kget puffins OYAML pipe to grep case insensitive Charlie. There we go. Name is equal to Charlie, and right here, color is equal to blue. So we were able to make a blue puffin called Charlie. Okay, so anyway, let's tie all this back together really quick, and then we'll look at docs, and I'll get out of here, because we're already about 20 minutes after the top of the hour. Okay, so we were able to actually go in and define various CRs, which are single instances, singletons, of our CRD, which is a type or kind puffin of group birds. And we wrote a controller for that using Kubebuilder, and the controller has this reconcile function here. Now, notice that when we did the reconcile function, we actually had to use the Kubernetes native client workflow, which is this little line here and this little line here. And again, this is like a Kubernetes like convention. Like if you actually go and look at the controllers or you interact with any of the API machinery code, these patterns are going to, or client Go even, these patterns are going to be very familiar to you. And the operator SDK before, on the other episode, actually gives us a thin shim on top of that so that we don't actually have to drill down and do the namespace and everything like that. It kind of does that for us, and then we'll watch given a certain interval. So this is a little, gives us a little more flexibility, but we're exchanging that flexibility with complexity. So it's a little more complex, but you can still get the same functionality that we got with the operator framework. So we were able to get a unique puffin, and we were able to update a status and actually pull a directive out of a CR and work on that here in Go code. So in my mind, once we're able to do all of those things, we can come in and actually get this to do whatever we want and whatever is important to me in my software organization. So that's sort of like the end-to-end round robin of going from YAML to Kubernetes into Go code and then deploying and what that whole workflow looks like. So last but not least, let's check out our docs, and let's check out our docs. So it says we can run Kubebuilder create, which we did all of this already, and then it says we can just run Kubebuilder docs. So let's see what this does. Kubebuilder docs. While we're waiting for that, sneak in some more rainbow wine. So it says it's running go run, package generated, open API, command main.go. Oh wow, it's doing a Docker run. Index.html saved. Oh, it even wrote JavaScript for us? Yes, I love when I don't have to write JavaScript. And it says reference docs written to docs reference build index.html. So let's go in here. Oh, that was cool. We actually got to see it repopulate live here on my screen. We now have this docs directory that wasn't here before, and then in docs we have reference, and then we have, where was it? Let's go back to my terminal. In reference, oh, we had build index.html. So let's go and let's look in build. Oh, wow. So this looks like it's a pretty complex website that we're going to be generating here. And then we have index.html. So this is a cool tool for folks who are running on a Mac, and there's also a Linux alternative. The Mac version is just called Open. Linux, I think it's WG-Open. And that's just basically like open this file using whatever the default opener in your GUI would use, that your GUI would use. Sorry about that. So we can do index.html. So let's do open, docs, reference, build, index.html, resize, and we have now generated our documentation page that we could host online, like stick it in S3 or even run it in Kubernetes, and we actually get documentation for our controller as well. So this is pretty handy because, you know, within the course of an hour and 20 minutes here, I've been able to create a custom controller, create a new version and scale my custom controller, define a CRD, define 3 implementations of my CRD using CRs, and then actually generate API documentation for it as well, all using Kubebuilder, which is pretty handy. So here we have our API version, our status, we have Puffin status, we have our Puffin v1 beta 1, so we could scale and create more APIs as needed, and then here we have color, excuse me, which is one of the directives we added to our Puffin spec earlier, and it says insert additional spec fields, desired state of cluster, important, run. Okay, so this is the comment that we see above. I bet if we go here, we can update our docs really quick. Let's see if we can do this. So episode 40, live. Let's go into package. Let's go into APIs, birds, v1 beta 1, Puffin types. Above color here, I bet we can do delete this line and this line and add a comment that says this is the color of the Puffin. Set this to any color string you like. Save that, jump back in our terminal. I bet we can do a Kubebuilder, was it docs? Let's see, and then rerun our docs, and I bet we'll be able to update our color directive there, which shows how you can easily create your documentation using Go Docs and then push that to your documentation site just by making a simple code change. Cool. So let's zoom back out and get out of here a little bit while we wait for our documentation to build. And let's do our open command again. Scroll down. Aha, we have color. This is the color of the Puffin. Set this to any color string you'd like. So now we're defining arbitrary directives. We're defining documentation for it. It's showing up in our docs. We're starting to really feel like real software engineers here. This is pretty exciting. This is a really slick tool. As somebody who interacts with a lot of the lower level Kubernetes libraries like the ones we interacted with today, this is kind of comfortable for me. I think I'm going to probably use this to create arbitrary controllers moving forward because it gives me a really, really powerful springboard into to getting a lot of this boilerplate out of the way. And the documentation here seems, it even goes in and it talks about all the different field definitions. Okay, so the documentation here is pretty slick. But yeah, I think, we'll do the recap that I do every time I do TGIK. We'll say everything one time that we did, and then I'm gonna get out of here because it's, we're an hour and a half in, and I got a mountain to climb this weekend. So yeah, we were able to create a directory live on TGIK. We were able to generate a lot of syntactically correct Go code that compiles, and we were able to define an arbitrary API, different resources and different groups, and version those using the fabulous.f domain name. We generated the YAML to actually run the controller that reads from these CRs and CRDs in Kubernetes. We were able to deploy to Kubernetes, and we were able to update our controller with a new copy of software that we wrote live here on the air, and that controller was able to update a status and read an arbitrary directive that we defined in Go. Doing all that and then pulled up our documentation, I think this has been a great episode. I'm really impressed with Kubebuilder. Hats off to the folks in API Machinery for putting this together for us. This is not an easy task to do, and if you've ever tried to mess around with doing this from scratch or copying and pasting another project before, this is not easy. So this made it really great and easy for us. So thanks for coming, everybody. I hope you all have a great weekend, and we'll see you all next week on TGIK. Thanks.